on page, the chapter 4 review on page 244, number 54. So to start out this question, you first draw a diagram of the field, which is x meters long, and it's capped by two semicircles, which is r radius. So an equation that's given for the circumference of the circle is, or the circumference of the circle is 400, which equals the two lengths of the rectangle, so 2x, plus the circumference of the semicircle, which is 2 pi r. So we want to isolate one of the variables, so I'm going to isolate r. No, wait, I'll do x. So x equals 200 equals x plus xr. So x equals 200 minus pi r. And then to find the area of the field, the rectangle, the equation would be the length times the width. The width is 2r, so that would be x times 2r. And so plug in the our equation here into the area of the rectangle. So that would be 2, or not plug and substitute, minus 200 minus pi r times 2r. And if we multiply those together, that would be 400 r minus 2 pi r squared. And, well, this could be the function of x, or actually r. So equals, if we find the derivative, where the derivative equals 0, so f prime of r. So first find the derivative, which is 400 minus 4 pi r. Bring the 2 down, so that's a 4. 2 minus 1 equals, so where the derivative equals 0 is the maximum. So 0 equals 400 minus 4 pi r. So that would make 4 pi r equals 400 and pi r. Or let's just go right to r equals 400 over pi, or 4 pi, which equals 100 over pi. So that's the length of r, of like half of the width. And then to find x, you just go back to this equation. So that would be, and substitute r into the equation, which is 400 equals 2x plus 2 pi 100 over pi. And then we solve for x. So that'd be 400 equals 2x plus 200 pi over pi. So that's 200 equals x plus 100. So x equals 100. So the question asks, what are the values of x and r that will give the rectangles the largest possible area? So these are the values. So 100 meters for x and 100 over pi meters for r. And to check if it's a maximum or minimum, we can find the second derivative of this function, or this function, and to see if it's a concave up or down. So the second derivative of r equals negative 4 pi, whoops, yeah, 4 pi. Okay, so since there's a negative, it's a concave down, which means concave down on a x and y axis. So the point up here would be the maximum, which is what we found here.